So having taken you back to 1998 might take you a little bit further back. Just before I do that, monitoring. We've probably got a screen like this, maybe. This is my mock-up monitoring display. It has, if it's sensible, maybe you prioritize it into different levels: critical, error, warning, info. Maybe it puts the most important ones at the top in red to make it easier to see which is more important. It's a good idea to prioritize them like that. Maybe it has some sort of filtering feature, so you can filter in and out what you want to see. Maybe you've got different teams. You want to look at different devices. I don't want to see all the printers, because I don't care about printers. But I do want to know about core networks and other important stuff like that. So it has those sort of abilities, those kind of features. The hard part of this, as I've discovered doing this over the years, is how to correctly prioritize these alarms. It's a bit of a tricky thing to do. How do we handle dependencies? Okay, if some router goes away or a switch goes away and there's a bunch of stuff behind that, then are you going to get a whole load of alarms because, I can't get to any of this stuff? But what's really going on, and how do we handle those dependencies? Speed of alert versus accuracy or usefulness. Yes, I can tell you about it in 10 seconds, but if you'd have waited another minute or so, I might have been able to correlate a whole bunch of other alarms that come in, and now I can tell you something more useful. So I can tell you something with a little bit of delay, which is more useful, or I can tell you immediately when something goes down. So there's a bit of a balance of, yes, I want to know now, versus you're going to get a whole pile of alarms because, I told you about that one, and then that one, and then that one. So you get 5 alarms, or do you get one alarm which is more useful but delayed a minute or two? Maybe we can correlate what's going on so we don't flood you with more alerts than is necessary. Alarm floods, it happens, something goes down, you get a whole pile of alarms, this screen goes completely mad. I think twice, when I was working for a place, having implemented a shiny new monitoring system, then did a live demo of it in front of 100 people. And twice there was actually an outage in the middle of my live demo, and all these alarms came up. Well, at least I can show the system works. A bunch of pages go off at the back of the room. People are like, what's going on? Anyway. Perhaps the even harder part, root cause analysis. Are we doing root cause analysis? Yeah, right. So we totally are, yeah. Will the operator understand the alarms when they see that screen? Will they know what's going on? How long is it going to take them to figure it out? Is the alert itself easy to understand? If they don't know what it means, or it's just literally a pile of jargon, then it's going to be hard for them to understand what that alert actually means. It could be really important, or it could be nothing. It doesn't give them the ability to understand what it means. Is it linked to useful, concise documentation or some process? Can I click on that and go, right, tell me what this is? I've never seen it before. Just happens to be working today, and it's me sitting here. What does this mean? What do I do? How do I log in? Yeah, we've all got really good documentation, right, haven't we? I can totally click on that alarm, and it takes me straight to what I need to know, how to log in, what problems I need to start looking at first. Decision support. There could be more than one thing going on at any given time. 2 things could happen at once. Mind blown. Which one am I going to prioritize? Which is the more critical of the 2 or more things that have just come in to my monitoring system? Does the monitoring system support my decision about, okay, they're both important, but this one is more important than that one, so that's the one we need to work on now, and then we have to come back to this one. That's kind of the hard part, really, that slightly awkward bits of implementing monitoring. Probably impossible to solve. Situational awareness. People get overloaded, they get stressed. You have cognitive bias in there as well. Your brain doesn't quite work in the same way when you're stressed. You start making sort of lazy, well, not lazy, but mental shortcuts to go, okay, I've seen this in the past, let's do it. Cognitive bias is a really hard one, really hard to crack. Unfortunate happenings, co-occurrences. There was a coincidence, two unrelated outages just happened to happen at the same time. You get a whole pile of alarms, and now you've got to sit there and figure out, oh, is this all the same thing, or is this two separate things? And your brain sort of go, oh, well, okay, now I think it's one thing completely, different thing entirely, but actually it was two separate things. It was just you got unlucky that they both happened to happen at exactly the same time or around the same time. Co-occurrences, I've had both of these happen. I take some corrective action, I go, and then the alarm clears, and I go, oh, fine, thank you, I can breathe a sigh of relief. But actually, it was just a coincidence. The thing I did had nothing to do with the alarm clearing. It just happened to go away by itself, or some other thing came back up, and so I think, oh, I fixed something, but it had nothing to do with it. It was a coincidence. And alarms occurring following an unrelated change. I was making some changes over here. Just so happens a whole bunch of alarms came, and I think, have you just broken something? Because I got a button, and it actually had nothing to do with what I did. But then in some situations, it's going to be really hard if you've spent a lot of time to, prepare for all of your changes and all of your stuff over here, and you've got some manager saying, you have to back out everything that you've just done because we see a big pile of alarms and we don't know why. And you go, honest to God, it's got nothing to do with what I've just done, honestly. So you can end up backing out a whole pile of stuff that actually had nothing to do with you in the first place. So those coincidences and co-occurrences happen. Not too often, but reasonably frequently to be kind of interesting to deal with. Situational awareness. I said when we get stressed, your brain starts thinking differently. You rely on mental shortcuts, faster decision making, but you're not really then able to take a step back and go, oh no, hang on, I'm not right here. I've come to some wrong assumption about what I think is going on. So you build a mental model of what you think is happening, but that's probably not, when you're stressed, that might be not what's actually happening. And when you go down that road, it's virtually impossible to take a step back and go, no, I've got this wrong. How about let's scrap that thought and start again? And probably several times I've been in the middle of this going, oh, what's going on? And then somebody else walks in and goes, oh, have you checked that? And you go, oh, no. It's not that they're a smart ass, it's because it's a fresh pair of eyes. They haven't gone down that road of the cognitive mental model that I built up. They've started at it from fresh, and they're able to see the obvious that I couldn't see. Very cognitively costly thing to do when you're in a stressed situation, to reevaluate everything. You probably can't do it very easily. Lots of cognitive biases, they're fun to look up, there's loads of them, just how we think, the way that we work, what emotions we feel that day, what we think about certain people, or how we feel about loads of cognitive biases, availability, heuristic, stuff that comes easily to mind. We estimate the probability of something happening in the future based on our memory of events in the past. I did this many times before, it was fine then, or this went wrong before, I might overestimate the risk of doing something the next time, or I could get overconfident or overcautious based on my experience, based on previous events. As, oh, I'm not going to touch that thing, a bad thing happened last. So all of these cognitive biases come into play. Co-occurrences and coincidences, two unrelated things. The state changed but was unrelated to the action. Coincidences really suck. It really sucks. And the classic example of a coincidence, there was more to it than just this. It was a whole series of events and circumstances that led to this air crash in Kedworth in January 1989. And the summary is a blade came detached from the fan of the left engine. The pilots didn't really know at that time what the problem was. They heard a loud noise, lots of vibrations. They were trying to understand what was going on. They then throttled back the working right engine instead of the malfunctioning left engine. There was a fire in one of the engines. They were not sure which one it was. And the situational awareness of it, they're now stressed and thinking bloody hard what's going on. They kind of came to that wrong conclusion. And now they eventually came to the realization that, just because it was a coincidence, we shut down the right engine and we stopped hearing the noise and the smoke wasn't coming in anymore. So they thought, okay, we think we've correctly dealt with the situation now. As it turned out, that was a coincidence. The design of the aircraft just didn't lend itself to that, so they thought they'd done the right thing. And by the time they realized they'd shut down the wrong engine, unfortunately it was too late for them to do anything about it. They couldn't restart the engine. I'm not going to talk about air crashes and things like that, because I don't think it's all particularly useful in this context, but if you want to read a report where they've sort of really learned, this kind of coincidences happen, and it's really stressful and really hard to work out, then that's a good report to go and read. There are lots of them. 1994, I'm going to take you back a bit further now to 1994. About that time, I was working for a big process engineering company called Foster Wheeler. They're building chemical plants and oil refineries and railways and all sorts of stuff. I was doing IT support back then. A bad day at the office. One day, I think a plant that we just a few months before handed over the keys to, I turned on the news one day and the whole thing was on fire. And I'm like, I guess that site's down then. We couldn't ping it. This was Milford Haven in Pembroke. If you don't know where Milford Haven is, it's just on the Welsh coast. There's a few oil terminals, oil refineries there. Not so much anymore, but it was quite a lot then. There are still some there, but not so much, not as much as it was. I think probably all this is long gone. But so the whole thing was on fire. We were just looking at what has happened. Milford Haven. There was an investigation into what happened, which is really useful. And a lot of things came out of that, which changed the industry, and it changed the approach about monitoring, alarms, control room design, making the thing easier to understand. And we can learn actually a lot from that. There was a lot of stuff about the design that didn't make it particularly easy for the operators to understand what was going on. That was the control rooms. Maybe looks a bit like a knock. And what had happened was there was a thunderstorm coming in, and they began to shut down parts of the plant. And I think there was actually a lightning strike. So the operators began this kind of routine process of shutting down the cracking towers, so the huge towers that you see in oil refineries where it's all split out into different products. Those have to be shut down. So when the storm comes in, if it does hit, then the whole thing doesn't blow up. So they began that, and some valve got stuck somewhere or failed to close or open, and the whole thing then just lots of alarms started coming into the control room. They weren't sure what was going on, and actually the whole thing lasted about 5 hours from beginning to end. They were trying to understand what was going on, but there was then a report that came out a little bit later called Better Alarm Handling. So we kind of learned from that. And it's an interesting report. Actually, it injured 26 people and it caused about £46 million worth of damage. There were too many alarms and they were poorly prioritised. Control room displays did not help the operators to understand what was happening. Inadequate training for dealing with a stressful and sustained plant upset. They didn't know how to react exactly. They're like, okay, and one of the ergonomic things of, yes, you've got in the last 11 minutes before the explosion, the two operators had to recognise, acknowledge, and act on 275 alarms. Now, if that happens to me, I'm kind of, okay, that's quite stressy. But the data center won't explode in a huge ball of fire if I sort of fail to understand what's going on. I won't comment about whether sometimes I might want that to happen. But it doesn't blow up, so the stakes are not quite as high. But actually, it's purely an ergonomics thing, a human factors. An alarm comes in, they'll read it off the display, they turn to the huge wall of manuals behind them on the wall, pull out the massive file, and they're, right, okay, so what does this alarm mean? Oh, okay, that's this thing here. So they were literally, it wasn't quick enough. They just couldn't understand what was going on in that 11 minutes before the site blew up. Reviewing your monitoring. How many alarms are there? Are they all necessary, requiring operator action? Have you got a lot of unnecessary, silly alarms? Nobody cares about this. Why do we monitor it? Should it go to some other system? How many alarms occur during normal operation? It shouldn't be that many. How many occur during a plant upset? How many standing alarms are there? I'm sure we've all probably got alarms that have been on there for weeks and weeks or months and months, and this leads to just people ignoring it. And remember that the thing, while there's an alarm, isn't being monitored correctly anyway. So you're kind of thinking, well, we've suppressed that or we're ignoring it permanently, and that's not a good situation to be in at all. So yes, the answer, set alarm rate targets. The long-term average alarm rate during normal operation should be no more than 1 every 10 minutes. That's what HSE sort of recommended, no more than 1 every 10 minutes. We might get away with a few more, depending on how many people are sitting in the control room. Usually it's just 1 or 2 people. No more than 10 displayed in the first 10 minutes following a major plant upset. That's really hard to do, really hard to do. Ask the operators, are they ever overwhelmed by alarm floods? Are there nuisance alarms, stuff that goes off all the time? They go, yeah, just ignore it. It happens every day. This happens, you just need to do this. This is kind of not a good situation to be in when you're sort of routinely having to ignore things, nuisance alarms. Is alarm prioritization helpful? Have we got it completely wrong by telling you this thing is really critical and important when you know this isn't a critical important thing? And you go, oh, no, it doesn't matter. It says it's important. Really not. Have you got it right? So the displays, are they well laid out? Are they easy to understand? Is clear help available, written or on screen? How easy it to navigate the system? All of these factors come into play. And yes, this is from the HSE report, but this is kind of familiar, isn't it? This sounds really familiar. Yeah, again, what I said earlier is like, are the terms used on the screen the same as the operators use? Are we using the same language? If they don't understand that alarm, they have no hope of being able to fix anything. Effective alarm prioritization, define prioritization rules and then apply them consistently to each alarm in every system. You can't have one system over here, another one over there. Well, they're not the same. What one thing calls critical, one thing's error. How am I supposed to understand that? Use about 3 priorities. Don't overdo it. Base priorities on potential consequences if the operator fails to respond. What happens if nobody picks up that alarm? What's going to happen? Hopefully it won't blow up in a big ball of fire in our case, but that would be a reasonable measure of what you should be basing it on. You can do proportionality, how many alarms of each type are we going to aim for, that sort of thing. The human limitations, okay, can we physically actually do the task? Can we physically respond to these alarms? This all comes down to training, understanding what what the limits are, having a defined response to each alarm, a good process to say, yes, if this happens, you need to do this. This is the procedure. Allowing enough time for the operator to respond. Okay, if an alarm comes in, you need to get that alarm to me before all hell breaks loose, preferably, or before even more hell breaks loose, and then for me to understand, this is what I need to do. I need to take the action as well. Familiar stuff. So what are we doing? A bit of ping 20 years ago, a bit of Nagios, a bit of MRTG, RRD, Cacti, Open NMS, all the open source monitoring systems that we know and love. What are we doing today? A bit of ping, a bit of Nagios, MRTG, RRD, Cacti, Open NMS. There's a few variations and forks of these. And it's not to say that these tools are bad tools, otherwise we wouldn't still be using them. They wouldn't have lasted that long. But have we really put as much into it as we could? Can we make this better? I know some of the larger providers have definitely got Ofcom knocking on their door saying, actually, we do want you to really care about this stuff. We need your assurances that if there's an outage, you're on it and your monitoring system works properly. And it's kind of, I think we can do better. Thanks. Don't know if there's time for questions, but I can catch up.
Any questions for Rob?
I've just got to go and do a phone call, Robert. I'm glad you finished. I was showing a customer around our NOC once. I was showing a customer around our NOC once, and we,
Never do that.
All the screens with the alarms, and I stopped with one of the support guys and said, "What are we looking at?" He says, "Oh, I'm just looking at an alarm in this particular customer site," and it was the same guy that was showing round. No, these things happen, right? And from the customer's perspective, it was great because he thought that we were on it, right?
You can see the whole thing playing out.
I think it might even have been one of the Milford Haven Royal refineries, actually. But
yeah.
Very quickly, I mean, one thing that Rob said there that cannot be underestimated is the human factor, startle factor. No matter how good the monitoring system is, no matter how good its prioritization or its correlation, you're always in a fog of war where you're not entirely sure exactly what's going on. And this can be, the cognitive biases are horrific. I've done a talk about this in the past, especially, and everybody's got that one device on their network where they go, that bastard thing. and especially, and that thing could be behaving itself perfectly, but the suspicion is on it if it's anywhere near the blast radius of the problem you've got, and it's so hard to back yourself out of that. And I've said this before, it doesn't matter whether the person you're arguing with is the CTO and you're the newest engineer. Tell that person, just be another set of eyes, just think it from first principles, because it really, really helps just unwinding somebody's thought processes.
I got one already. To further on to Paul's point, actually, around when I had a particular tire fire of an operations job, a lot of the thing that really mattered during alert explosions was just like psychological safety in the job, like being sure that even if I did completely cook something, that I was not going to get particularly yelled at by a manager or something. There is a lot of internal culture around, even if the tire world is exploding, even if your alerting system isn't very good, and it's giving you like 10,000 alerts in less than 30 seconds, just knowing that you're not actually going to be in too much trouble if you don't handle it correctly speaks wonders. Out of interest, you mentioned around, this is a three-parter, I'm really sorry. Secondly, the thing that worries me a lot about how the internet works, so the oil refinery disaster is interesting because nobody died. People were injured, which is bad, but nobody died. And I think that's a lot of the frustrating thing about how the internet operates, in that it's genuinely quite rare in fact, I don't know an immediate case of an internet disaster causing somebody to die, which means that we don't, as an industry, take it very seriously when we have some pretty basic mistakes. But the thing that really worries me around that is that with things like the PTSN network shutting down and things going entirely into VoIP, this stuff now matters. Like, whether the case of, importing bad BGP routes, which is the immediate one that comes to my mind at least, right? And like your VoIP traffic disappearing, that means someone can't call 999. That's potentially fatal. So that's something that worries me a lot, and I would assume also worries the regulator, hence their recent involvement with this.
Yeah.
Deferred of that, I'm genuinely just curious for an audience poll, really. How many of you are still using Nagios or derivatives of? I'm just curious. Is there a hand raise?
There's no.
What about
There's
Prometheus?
no right or wrong thing. Is there? Yeah.
Oh, you're using both. Okay, cool. Well, fine, fair enough. I was just curious on what the industry was currently operating with. That's it.
Okay. I think I have to wrap it up there, but.
Yes, thank you very much, Rob.
Okay. Thanks.